Here's lesson 2.1, linear measurement. So it's common in Canada to see lengths and distances measured using two different measurement systems. The metric system is used in Canada and throughout most of the world, and the imperial system is also used in North America and the United Kingdom. Wherever you use or seen the metric system for linear measures, give some examples. That might be things like speed, okay, road signs, any sort of distances around a track. So 400 meters, 1,500 meters if you've ever run sports. Okay. You may have seen it in schools with rulers, any sort of measuring device. Okay. Things like liters of water, liters of gas, so at the gas pump, you can write those things down, and any other examples. Where we've seen or used examples of the imperial system. So miles per hour, that would be in the States. So a gallon of paint. Anywhere where you see like a tablespoon or a teaspoon if you do any cooking, those are things that are in the imperial system. All right, so getting started, calculate 1/2 times 20. Well, on your calculator you can type in 1/2. If you remember, 1/2 is also the same as 50%, so you're multiplying 50% times 20. So 0.5 times 20, and you should get 10, or half of 20 is 10. A quarter of 24, so 0.25. This is the same as 0.25 times 24. That gets you 6. Over here, 3/8, so you'd go 3 divided by 8. That equals 0.375. And you're going to multiply that by 16. And you get 6 and 7/16, so 7 divided by 16. That'll get you 0.4375, and you multiply that by 32, and you get 14. Here's some more. Calculate 2.5 times 1. Well, anything times 1 is just itself. 68 times 10, well, that's 680. And move over here a little bit. 0.125 times 100. Well, anytime you multiply by a multiple of 10, you just move the decimal however many zeros you have. So that becomes 12.5. And here we have 3 zeros, so we're going to move this 1, 2, and we don't have anything, so we move it and we add in a 0. So this becomes 7, 2, 5, 6, 0. Describe a pattern for multiplying any number by a power of 10. Well, you move the decimal to the right by the number of zeros you are given. So that means there's 3 zeros, so you moved it 3 spots. There's 2 zeros, so you moved it 2 spots. Evaluate 10 squared. Well, 10 squared is the same thing as 10 times 10, which is, well, we've got 1 0 here, so we move it once, is 100. 10 to the 3 is the same thing as 10 times 10 times 10, which is 1,000. All right, so this 0 here moved it once, and then we have another 0, so we moved it again. So we ended up with 3. 1/10 squared. Well, we know that 10 squared from this example here is 100. So 1/10 squared will give you 1/100. 1/10 cubed is the same thing as 1/1,000. The 10 cubed here is the same thing as the 10 cubed here, but it's just under 1, so it becomes 1/1,000. All right, here's some more. Evaluate 67 divided by 1. Well, that's just the same thing as 67. 355 divided by 100. Well, if we're dividing by 100, we're going to move the decimal back 2 spots, so this becomes 3.55. 96 divided by 10, we're going to move the decimal back 1 spot, so we get 9.6. And we're going to move the decimal 3 spots, so 1, 2, and we don't have one, so we move it, and we add in a 0, so it becomes 0.02375. And describe a pattern for dividing the powers of 10. Well, you move the decimal to the left, not the right, to the left by the number of zeros you have. Okay, put these measurements in order from least to greatest. Okay, let's just think about this. 2 kilometers versus 265 centimeters. Well, 265 centimeters is clearly less than 2 kilometers. 4.8 meters, well, 4.8 meters I think is bigger than 265 centimeters. And 1,000 millimeters, well, millimeters are the little ones on the ruler. So I think it's going to go 1, 2, 3, 5 millimeters. Then it's going to go 265 centimeters. Then it goes 4.8 meters. And then it goes 2 kilometers. All right, calculating. Round each product to the nearest tenth. So the nearest tenth, if we look at our chart, 0.000. Okay, so this is tenth, hundredth, and thousandth. Okay, sorry about my messy writing. So we're rounding it to the nearest tenth. So that is, oops, that is not a very fine highlighter. Let's try that again. Okay, the tenth is here. So you would go, this becomes 59.9 because the 2 does not affect it. Okay, so 25.7 times 17.5, you pull out your calculator for that one, and you get 25.7 times 17.5. You get 449.75. We round to the nearest tenth. So the 5 does affect the 7, so we get 449.8 is rounded to the nearest tenth. Next one, 0.5 times 0.95. We get 0.475. And if we round that to the nearest tenth, that becomes 0.5. 12.84, so 12.84 times 15.36. You should get 197.22. And that is about 197.2. Okay, we got some more completing each pair of equivalent fractions. Well, here in the first one, I know that I need to multiply by 2 to get to 16, so if I multiply the top by 2, I'll get 6 over 16. Here I need to know I divide by 9 to get to 5, so if I divide that by 9, I'll get 3. Here I need to know if I divide by 8, I get 4, so if I divide by 8, I'll get 3. Here I need to multiply by 1.5, so if I multiply this by 1.5, I should get, hold on here, 6 times 1.5, and you'll get 9. So 2 over 6 is the same as 3/9. Okay. Circle the ratios that are equivalent to 4 over 5. Well, let's think about it. If I multiply 4 by 4, I'll get 16. Let me get my little thing here. So if I multiply 4 by 4, I'll get 16. So if I multiply 5 by 4, I get 16. Or sorry, 20. So that one is good to go. If I divide 4 by 2, I'll get to 2, but I can't divide 5 by 2 to get to 3. So that is not one. Here if I multiply 5 by 2, I'll get 10, but if I multiply 4 by 2, I only get 8, so that is not one. If I multiply 4 by 3, I'll get to 12. If I multiply 5 by 3, I get 15, so that one is good to go. Okay. Here's another one. If I multiply 4 by 8, I get 32. If I multiply 5 by 8, I get 40, so that one's good. And last one, if I multiply 4 by, well, let's go the other way around here. I'm going to divide 64 by 4. So I need to and I get 16. So the other way applies. If I multiply 4 by 16, I get 64. So what happens if I multiply 5 by 16? What do I get? So 5 times 16, I get 80. So this does work out as well. Okay, last one. Last couple here. I'll leave these ones for you to do. All right, or I'll go through them. Ratios. Okay, so Tanya knows that the ratio of boys to girls in her class is 3 to 5. Since 20 of the students are girls, she says that there must be 30 students in her class. Is she right? Explain your thinking. So boys to girls. So this here is boys, and that's girls, okay? So since 20 of our students in the class are girls, well, what do I have to multiply 5 by to get to 20? So 5 times 4 is equal to 20. So then 3 times 4 gives me 12. So there should be 12 boys in the class. Well, together, that gives me a total of 32, which is not the same as 30. So she is wrong. Bandits won 9 of their first 20 soccer games. If this continues, how many games would you expect them to win in 30 games? Well, let's check this out. If they won 9 out of 20, how many would they win out of 30? Well, I need to multiply 20 by 1.5 to get to 30. So if I do the same thing up top, I should get, what should I get? 9 times 1.5 is equal to 13.5. So they need to win around 13 or 14 games to have the same success ratio.